Hello everyone, we're going to take a look today at a few of the problems that people send in to say that they're having problems setting up Mach 3. Many of them have been using Mach 2 in the past, but some people have a problem upgrading from Mach 2 to Mach 3. And I thought it's a good idea to go through some of the most common problems so that you can see a few things to check on your own, so that it doesn't drive you too crazy when you're trying to set up the controller. Now, many people get Mach 3 booted up to the state that we see on the screen now. The biggest problem that affects people is, for example, right now you can see I'm jogging. When I'm jogging, the DRO for the x-axis, for example, up here, is moving, and the y-axis moves. And the biggest problem that is reported is people saying, the DRO moves, but my motor doesn't move. What could be the problem? Well, let's take a look at what the problem is here. On this system at the moment, the DRO is moving, but my motors are not. So let's take a look at the most common items. We're going to go up to Configure, Ports and Pins. Under Configure Ports and Pins, you can see that we have port number 1 enabled, and it's at address 378. If you have any questions as to whether 378 is the proper address for your machine, watch the first video on setup and download of Mach 3. It shows you how to check your control panel of your computer to make sure that the port address is proper for your computer. There's about 1 or 2% of computers out there which do not use 378 as their core address for a printer port. Some of them use C000 and some other PCI addresses. It's an unusual problem. The vast majority use 378, so it's probably not your problem. The next thing that we can see on that screen is that the Mach3 CNC mode is enabled. These modes under Mach3 CNC are only for a particular type of machine, and they change the output characteristics of Mach 3. Instead of step and direction, for example, Mach3 CNC mode is a quadrature output. It puts out an A and a B signal, much like an encoder does, and this causes the motor on a Mach3 CNC to move. So we have to turn it off. If we enable Mach3 CNC wave drive, this causes 4 pins to go out the system for every pulse. The 4 pins would correspond to the 4 wires on a motor. So we've turned that off, and now we need to check our motor outputs. This is a very common screen that I get from people that are trying to set up Mach 3. First of all, you can see that all the step and direction pins are set the same. This is obviously wrong. Now, on this particular system that I'm using, it's actually pin 2 for step and pin 3 for direction for the X motor. The Y motor is 4 and 5. The Z motor is 6 and 7. Now, I also get many screens that look like this with people saying, okay, I've done this, but why do I still have no movement? Well, the thing that you have to notice is that over here on step port and direction port, they're set to port 0. There is no such port. So set these to port 1 as such. Hit apply and OK. And now my motors are moving. Now a secondary complaint is, okay, my motors move, but they move very slowly when I jog. Why would that be? Well, as you can see, if I hit jog, I'm going to 120 millimeters per minute on this system. If I hit the tab key to bring out the jog tab, and incidentally, to control the jog tab, drag it out so that it is on your system facing you and you can read it fully, tab it in, tab it back out, and it will remember its location from then on. The jog rate down here at the bottom, you can see it's set to 100% on mine. That can be set to any value, so make sure that it's set to a value that you want it to be for your slow jog. There are 2 forms of jog in Mach 3, and it's not atypical to set it to a value such as 30%. Now you'll notice these lights up here beside jog mode. There is continuous, there is step, and there is MPG mode. It should be in continuous mode for most people. Now there are 2 types of continuous mode. The first is when it's simply sitting on continuous and you jog, and you can see that my speed goes to about 36 because I'm running at 30% of maximum speed. If I hit the shift key, note the light beside the jog mode. It lights up to tell you that that is fast jog when you hit the shift key. If I hit the shift key and then jog, you can see now I'm going at full speed of 120 units per minute. The next question that often comes up is, how do I know that my axes are accurate? If I zero my X movement, and we go to the MDI screen, and we say G0X5, you can see that the XDRO moves us to 5.000. This is correct, but many people find that their system did not move 5. In actual fact, the axis may have moved only a quarter inch, or it may have moved 10 inches. This is all set up by the motor tuning steps per inch. And if we go up here and bring up motor tuning, you can see that for each axis there is a steps per. This needs to be set to the number of steps the system needs to send out to move your axes that amount. 1 millimeter or 1 inch, depending on the selection that you have selected for the system. The acceleration and the velocity you should set to a comfortable level prior to doing anything, and hit Save Axes for each axis. You can then adjust your steps per inch to make the system accurate. So if we assume here that our axis is now moving properly, but we're not sure what to put in steps per, we can just hit OK, go to the Settings tab, and on the Settings tab there is a button down here by the reset which is called Set Steps Per Unit. This will automatically calculate for you how many steps per unit you should use. For example, let's use it. First we'll zero our axes. We're then going to go to the Settings tab and press the Set Steps Per Unit. And we come up with a dialog which asks us, which axes do we wish to calibrate? We'll calibrate one here so that you get the idea. Calibrate the X axis. It asks us how far would we like to move this axis. We're going to tell it 5. Well, actually, this is a millimeter system, so we're going to click in there and tell it to move 10 millimeters, and we'll say OK. When we do that, the system actually moves. If we now measure the system, your axis would have just moved from its position to a new position. You have to measure that movement. If we tell it that we actually moved 5 millimeters, it will now set the axis to 4,000 steps per unit, which will be accurate. We say yes, and the x-axis has now been calibrated. If we now zero the x-axis and jog a particular distance, you should be able to measure that, and it should have moved exactly 2.1877 in this case. That takes care of the two most common problems that you're going to come across in Mach 3 and the two most common reports of trouble. Okay, so now let's take a look at two of the most common problems that people have on other sections. First off is people who wish to home their machine. They press the Ref All button and they get a message. Well, let's take one problem at a time. First off, we can see that the x-axis is moving forward trying to home. This is wrong on most systems. It should try to move backwards. So we're going to stop that movement and check to see why the X is moving backwards. If we go to Configure, Homing and Limits, here we can see that we have, first of all, a selection to reverse an axis direction. This is a general reversal, meaning if your axis is moving the wrong way when it's telling you it's moving forward, you could check that box and it would reverse the actual motor. Nothing would change in terms of operation of the program. It would look identical, but the motor will go backwards. Our X is okay. But you can see another box here that says Home Negative, and it's not checked. In actual fact, the X and the Y normally home in a negative direction. Only the Z normally homes in a positive direction. We also have a selection that tells it to auto zero. when it homes, and we can set a home speed. 10 to 20% is a typical speed for homing in order to get accurate stopping at the switch. We can also see here there is a home offset. Home offset tells the system how far away from the switch 0 will be. If, for example, I put a -1 in the box for the X home offset, and we check home negative, and we're going to auto 0, we now say OK. And we'll 0 the X, and now we'll tell the X to home, and you can see that the X is now homing in the negative direction. And it's going to home until the X home switch is seen, then it's going to move backwards, and then it's going to stop, and it's going to 0. Now there's one of the questions that comes up. As you can see, my X-axis went to home, reversed its position, and then it zeroed. But we have a number, -80 here. Some people look at that and think, well, there's something wrong, it didn't zero. But if we look at the machine coordinates, we can see it did zero. It zeroed to -1 because we told it in the home offset that 0 is 1 away from the switch. Therefore, if we now say go to 0, the X will move to 0. But, and I'm going to stop this here so that you can see it. Let's 0 this again. You can see we're at a machine coordinate of +61, and we're going to home the system. The X begins its traverse backwards towards the switch, hits the switch, moves off, and zeros. But what zeros is the machine coordinate, not the normal coordinate. This is a G54 coordinate, which is in effect. We can now hit 0, and we are zeroed with a machine coordinate of -1, meaning true 0 is 1 off of the switch. There are buttons on the diagnostics page to home each axis individually. You can see that we already referenced the X-axis, therefore we have a green light beside the X saying that it is a homed axis. Now we could reference the Y-axis, and you can see that it will not home. But looking down here, we get a message that says, requested home switch is active, please fix. What is going on? Well, let's push the X home switch and see what happens on this diagnostic screen. You see what's happening when I push the X home switch. M1 home is lighting, and when I release the switch, it goes out. The M2 home switch is acting backwards. If I push the home switch, the light goes out. If I release it, it comes on. And the same thing for the Z home switch. This is wrong. All LEDs on this section should be off unless the particular switch involved has been pressed or is active. There are two states to any switch, inactive and active. When it's pressed, it's active. When it's not pressed, it's inactive. So we have a problem with M2 home and M3 home being on. Those should be off. So we go up to configure ports and pins, input signals, and you can see that the Y home switch is checked for active low, but the light is on without the switch being pressed. Therefore, that's wrong. Whenever you see an LED on when it shouldn't be, go to your input signals and check or uncheck the active low. In this case, the Y is wrong, so we will uncheck it, and the Z is wrong, so we will check it. Hit apply, OK, and you'll notice that the lights are now off. If we go to reference the Y axis, it will now begin to move, and it will stop when it hits its switch. Same thing for the Z, it will move, and then it will stop. That's really all there is to making sure most of your switches work. Same thing happens with the reset, and this is a famous problem that many people report. If we look in our ports and pins, input signals, and slide it down to the e-stop signal, you can see that I have it set to port 0. This is because I don't use an e-stop button. But many people will have the active low checked. Actually, under port 0, it won't matter what you check. But let's set this to port 1 so that you can see an actual real-life problem. Go down to e-stop, and we're going to set it to port 1, pin 10. Now, I cannot reset my resets button. It says external e-stop requested. if I look in the LEDs, the emergency light is flashing. That emergency light should only flash when an emergency is being called for. If it's flashing and there is no emergency, then you simply need to go to ports and pins, input signals, slide down to the E-stop switch, and reverse the low active. This is true of all the signals in the system. If any signal is interfering with you or keeping you from being able to move, look at your diagnostics page. The diagnostics page contains important information. The first important piece of information is that all LEDs must be off unless they are active, and you know that they're active. For example, if you had an external jog on the X hooked up, this light under eJog X++ would be lit only when you're pushing the switch to jog the X. Second thing is your pulse frequency here. You notice my pulse frequency is 25,856. That's typical for my system, and it can vary. Some people will have 24,111, other people will have 28,600. But it should be fairly stable. As you can see, mine is not moving at all. It is locked constantly on 25,856. It's a very stable system. Time in interrupt is another indicator. This is the number of microseconds the system spends each of its 25,856 interrupts per second. So 25,856 times a second, the system spends 3.3 microseconds approximately dealing with your system inputs and outputs and handling your stepping. That's a fairly good number and indicates a fairly low load on the system. The actual load on the system would be 25,856 multiplied by 3.5 microseconds, which would be equal to about 90 milliseconds per second. So that's less than that's about an 11% load on your system, which is not too bad. Those are the most common problems that people come into when they're trying to set up Mach3 after having used Mach2. The important things to check: your ports and pins. Make sure all of the things on this side are unchecked unless you know that you need them. And make sure that your input signals on the LEDs are all out. And make sure that under motor outputs you have ports selected under step port and direction port, and that you have the pins set the way you had them set, 2 and 3, 4, 5, 6, 7 in this case, in Mach2. If you set these the same as you had them in Mach2, your system should now be running. That's pretty much it for making a system run Mach3 after it's been running Mach2. Now let's look at setting up a spindle in Mach3, because that is another problem which is constantly reported. We're going to go to the ports and pins, to the Spindle Setup tab. Now here under Spindle Setup, we have several choices for a spindle. First of all, are we going to use the step and direction output to control our spindle motor? Many people don't. Many people simply use a relay. So let's assume we're going to use a relay. You can see that on the left-hand side we have relay control, and it controls the spindle from output signals 1 to 6, whatever you want. First thing is, uncheck the disable spindle relays and set the relay number that you wish to use for your spindle. In this case, you'll see I have it set for output number 1 for clockwise and output number 1 for counterclockwise. I'm going to apply that and now go to the output signals. And you can see that we have outputs 1, 2, 3, 4, 5, and 6. Well, on this spindle tab, I selected output number 1 as my spindle relay. So under output signals, I'm going to go down to output number 1 and turn it on. It should be checked for on, port number 1, and you can see it's set to pin 0, which is wrong. We're going to set that to pin number 1 in this case. Now you can see that we also have an active low or an active high. If you turn on a relay and you find that the relay is on when it's not supposed to be, but it's off when it's supposed to be, that means it's acting backwards. Like all backwards problems, check the active low. Checking or unchecking this will toggle the state of the relay in each of its conditions. So if your relay is running backwards, your spindle is on when it should be off, you simply need to check or uncheck this box under active low. Once you do that, If we turn on the spindle, you can see that the spindle light is now blinking, indicating the spindle is on. And if we look at our diagnostics page, output number 1 is blinking. If output number 1 blinks when the spindle is on, that means that the signal has been enabled. If I toggle the spindle off, you can see that output number 1 stops blinking. Now you'll notice whenever I toggle the spindle on, we get a dwell active, just for a moment, and it shuts off. If we look at the configure ports and pins and go back to the spindle, you can see here under general parameters we have a spin up delay and a spin down delay for each direction. This is the number of seconds that it's going to take before the relay shuts off and before the system allows any G-code to continue. Now for some people, they want that relay to turn off immediately, but still wait for 1 second before the G-code continues so that the router has time to spin down. There's a checkbox here, immediate relay off before delay. You could check that. Let's set our spin down delay to 2 seconds. Hit apply and OK. I'm going to reset and turn on our spindle. Now we turn on our spindle, we get a 1 second dwell, and we can see that our output number 1 is flashing, meaning the spindle is running. If I now toggle it off, the second I turn it off, output 1 goes off, and then the dwell takes effect. And that's the action of that last checkbox I checked, immediate relay off before dwell. Another common problem that people have is they say, my printer port just doesn't seem to be working. It's not putting anything out. Well, sometimes charge pumps and things like that can make a breakout board not accept motor output signals. So let's take a quick look at how you can check your printer port to make sure it's working. We go to ports and pins, input signals, and we'll see that there is a button here called automated setup of inputs. If you're not sure whether active low should be checked or you're not sure what pin a particular signal is on, you can hit the automated setup of inputs. We can then see that we have a drop-down box with every one of the signals in the system in it. So let's say we're looking for the X home switch. We'll pick X home switch and we'll say auto setup. Now we get a message saying searching for signal activation. Press the switch or cancel. So let's push the X home switch on our table and see what happens. You can now see that the system says signal set to port 1, pin 10, select next signal. We can now hit OK. We can see X home is on, it's set to port 1, pin 10, and the active low has been set appropriately for it. The system did it for us automatically. Even if you use automated setup of inputs, you should take a look and see what it did so that you understand what active low does. It's important for every user to understand the effects of active low. It either toggles the state of the input that is seen as active, or it toggles the state of the output if it's an output signal. This row here, emulated, is something that should not be used unless you understand what it does fully. Turning on an emulated signal, such as X home for example, if we turn on emulated and then hit the hotkey box, it will ask us for a key. If I hit a key on the keyboard, say the letter X, we now have 88 as the hotkey for the X home. If I hit apply on that and then OK, if I hit the letter X on the keyboard, you can see that it is a home switch now. Not a good idea to set a letter X, by the way, because if you're in an MDI box and trying to type G0X7, you'll notice when I hit the X, the M1 home lights up. That's why you would not emulate unless you know what you're doing, because if you emulate to the wrong button, you will get bad results. So turn off emulation on inputs unless you actually need to emulate them with a keyboard key. Normally using hardware, you would leave that off. So active low is the important thing to check here. Make sure your port and pin numbers are set as they were in Mach3, and make sure that your port is not set to 0 on signals. Same thing with the output signals. Make sure that your port and pin numbers are set appropriately. You can see these are all set to port 0 because they're not being used. A signal that's turned on should never be set to port 0 unless, again, you're emulating it and you know what you're doing. That's it for the most common problems in getting Mach 3 to actually put out. A good way to check to see if your printer port is working is to use that auto pin input setup, because it will at least tell you if your printer port is working. If that routine works for you, your printer port is valid and your motor signals are likely going out, but your breakout board may be missensing the charge pump input, so you want to read the documentation on your breakout board to make sure that the charge pump is not your